So they can see me. Okay, you can see me. Can you also hear me? Okay, great. Don't see your screen. Ah, ja, natürlich. So, dat valt er niet zo op. Technical. Now we see ourselves. Okay. You're there.
Okay.
Oh,
are you guys there?
Yeah, I can hear you.
Okay, so I had to leave the room for various feedback reasons to introduce you, and I will do this very, very briefly because we're running late. So it's just my pleasure to introduce Mark de Paul and Jana Bru from the Catholic University of Leuven. Mark has been building a database initially of names and now including personal names, now including geographic spaces or entities and relationships. He's been at it since 2005. So there's 10 years of work, hundreds of thousands of names from open access Greek and Latin sources, Greek sources, I think, primarily, but also Arabic and Coptic and various other languages. And Jana is a researcher working with Mark, who really does spaghetti work, as her blog puts it, work doing social network analysis and trying to get at relationships and visualizations of those relationships that you can actually understand. And at that, I will shut up and let them get started so we can actually have time to do as much of this as we can. So, Mark and Jana, go for it.
Okay, well, thank you very much, Greg. So I hope you can hear me all right. The title of the presentation is Applying Social Network Analysis to Names in Trismegistos People. First, I wanted to briefly remind you what we do at Trismegistos. You can see the website here. It's actually not just a single project, as Greg has said, but it's several projects dealing with text collection, archives, and so on. And it's really very diverse because it has grown from a number of projects in Leuven over the years. And the oldest one of these projects even goes back almost 70 or even more than 70 years. That's the Prosopographia Ptolemaica. It's a prosopography of the Ptolemaic Egypt, and it was founded by Willy Peremans in the top right. And work on that has continued on and off for several decades, but from the late 90s onwards, Willy Clarisse, whom you can see in the bottom right, together with Kathleen van Dorpen, has been creating a lot of new databases of various things, like the Leuven database of ancient books is about Greek and Latin literary papyri originally and manuscripts. The Leuven homepage of papyrus collections is a database of collections that hold papyri, museums and university collections. The Fayoum project focused on a specific region in Egypt, the Fayoum, and the Archives project was dealing with collections of texts in antiquity. So all of these projects have found their way into Trismegistos, as you can see, to various extents. They have been brought together in this new whole, which we call Trismegistos. So what do we do digital humanities-wise in Trismegistos? Well, we deal with three things. The first of which is stable identifiers. We provide stable identifiers for a number of things, as I will briefly tell you later on. We then apply named entity recognition to full text. We don't do the full text ourselves. We hope that other people will provide us with corpora which we can use to extract things such as names and places. And finally, we do some social network analysis on the basis of the material which we have extracted. So first, stable identifiers. Oops, sorry. Trismegistos text was created actually as the result of a German project, the Kowalewskaya Award. I was granted this in 2004 to set up a project which was based in Cologne, and I decided to investigate multilingualism and multiculturalism in Greco-Roman Egypt, and for that I thought I needed a database with texts from Egypt between 800 BC and AD 800. So, unlike many other projects, we decided that we would focus on metadata of all texts. That is to say, we would not limit ourselves to a specific language, nor to a specific writing service, nor to a specific genre of texts. So we would do both literary and documentary, epigraphy and papyrology, and Greek, Latin as major languages, but also all the smaller languages. For the time being, we decided not to go into unpublished papyri because that would be a new thing. So in the course of this project, we brought together all of these texts from Greco-Roman Egypt and from larger, between 800 BC and AD 800. And as you can see, there were various partners here that helped us with papyrological material, documentary and literary in Greek and Latin and in all the other languages, but also with epigraphy. All of this would not have been possible, of course, without the help of these partners. Bringing all this stuff together, we were quickly confronted with the problems of identification. So here you see the Rosetta Stone. It's called the Rosetta Stone in English, but it has a different name, of course, in French and in German, so names are not very useful to identify, but neither are some of the other ways in which texts are commonly identified in scholarship. For instance, in Greek epigraphy and Greek papyrology, you have these publications, sigla, which identify text by referring to a recent publication. But of course, these publications change, and then that's a problem for a stable identifier. But also the system that was used in Egyptology, which are inventory numbers, for instance here, British Museum, Egyptian Antiquities 24. There are also problems with that because you can use commas, you can add the EA or leave it out, or you can add London, etc. So we decided that the easiest thing would be just to identify each text by a serial number, a completely meaningless serial number starting at 1 and going up as the project proceeded. This is what had become the Trismegistos identifier. And after the project in Germany finished, I returned to Leuven. We did a project on names, to which I will come back later. But we then thought, well, maybe it's a good idea if we expand Trismegistos a little bit and include even more things. Amongst those, also material from before 800 BC. I won't go into that now because some people asked us to add this material to Trismegistos. Also some unpublished material. We're trying to work together with various collections, and right now the British Museum, to add all their papyri, even the unpublished ones. But the main expansion, recent expansion, is that we have decided not to limit ourselves any longer to Egypt, but to include the text from the ancient world in general. And here is a survey of what we're currently doing. We have started by expanding with Latin epigraphy. We are part of a project, the Eagle project, which brings together several databases of Latin inscriptions, and we're integrating all of those in Trismegistos and assigning them unique stable identifiers. We also, because we have a certain sympathy coming from Demotic, which is my original specialization, I sympathize with minority languages, so we've tried to integrate as many as possible of those. And we are in close contact with Duke and other partners for Greek epigraphy to include the Greek inscriptions eventually also. And perhaps in the future we'll do even more, but I think we have another on our plate right now. I guess the eventual idea is to have a numeric identifier for all texts of the ancient world. We now have under 400,000. It's hard to tell what the eventual figure will be, maybe 1 million, maybe 1.5 million. So what are we doing all this for? The idea is to provide some background standardization. And if we do background standardization, we can communicate better. And if we can communicate better, we have to do less duplication of effort, and we just can go quicker. And I'd like to illustrate that by telling you something about the second thing we do, and that is the named entity recognition. For this, I'll focus on Trismegistos people. That's the green you can see at the bottom. At the top, you can see the text database, which of course provides us a lot of information also for the database of people and names. This is the result of a Leuven project. Between 2008 and 2012, we wanted to create a database of proper names, people, and places in the Trismegistos text, again, of all languages and any discipline. And we wanted afterwards to do socio-onomastic research with that. How did we want to do that? Well, we started from existing database. I've already told that Trismegistos text provided us with a lot of information. We didn't need to worry about the date of the text or the provenance because we already had all that information, and we could just focus on the onomastic and prosopographical information. We also found out that if you don't have a full text corpus at your disposal, it takes forever, especially for Egyptian. All of this work was manual and it took ages, and we're still not finished. That's quite in contrast, although there are many less Egyptian texts than Greek. We are finished for the Greek. We have done all Greek documentary texts, over 50,000 of these. And this is because we work together with the Duke database of documentary papyri. They provided us the full text in Unicode, which allowed us to extract the proper names. And an extra advantage for that was that only the proper names were capitalized, with the exception of some large figures. So we applied named entity recognition on this. You can see here the way we did it. So basically we tagged all capitalized items with either a yellow background for places or a green background for people. And then we also tagged specific expressions which linked various names in one identification in blue. So that here, this very long identification of a person is one cluster, which can then be analyzed by the named entity recognition. We developed a completely new system for this named entity recognition, also because there was a complication with the fact that in Egypt you can find both Greek and Roman onomastic systems, and they're very different. As you can see here, in Greek, 2 consecutive names are normally the name of a person and the name of his father, whereas in Roman onomastics, this is just 2 names belonging to the same person. And you can imagine that if you have longer identifications, as you often have in the Roman period, this gets very complicated. And you can see, for instance, by looking at the bottom example, this is all one person who's added both his Roman-style Aurelius name, but then also a double name. Some people had 2 names. Father's name, father also had a double name, a grandfather, a mother, and a maternal grandfather. And the system that we developed needed to be able to deal with this. And so we created a set of 165 rules which were applied to each naming cluster, as you can see here, taking into account the etymology of the name and the order of the different names and the nature of the small words in between, like here, tu and tukai. So if everything went well, the computer was able to recognize all clusters and interpret them perfectly. We checked all of this because there were quite a few cases where the computer didn't interpret it correctly, and we had to add some things manually. This was unavoidable to some extent because cases are also an important factor in the analysis, and sometimes also the ancient scribes make mistakes with the cases, and then it's almost impossible to deal with that in an automated way. The result of all this is a database of people with 2 different strands, you could say. One is the onomastic section, which you can see here, with at the bottom the reference database, which is a database of attestations of names, attestations of declined name variants, which is the database above. That's the database we use for the named entity recognition. There's, of course, this extra complication in Greek and Latin that you have all these different genitives and datives and things like that. Above that, each declined name variant belongs to a name variant. That's a database of name variants in the nominative. And on top of that, there is a database of names. The difference between names and name variants, it's perhaps easiest if I explain this by showing you this slide. So here you have the name Peteminis. That's actually an Egyptian name, Padi Min, the one who was given by Min. There's very little variation in Egyptian, but it happens quite often, that, of course, that if you render a name in another language, you get some variation, and there's quite a bit of that, as you can see here. And so this is the database of names, and on the right, this column, there is the database of name variants, which is shown here as well. The other strand is prosopographical. This basically is the distinction between attestations of people and people. Famous case being Zenon, for instance, the manager of an estate in the 3rd century BC. In Egypt, he has this large archive with so many papyri, and there is only one record for him in the people database, and there are many more, almost 2,000, of course, in the reference databases. We're right now also doing this on Latin inscriptions. There are many more Latin epigraphic text, almost 500,000, which leads to almost 2 million words, which should be investigated. But fortunately, the Latin inscriptions are shorter, so although there is more material, it's not impossible. We have some 860,000 clusters of capital words and linking words, of which we have now recognized almost 90%. And of the 400,000 where we think there are personal names in these clusters, we have also interpreted about 90%. Of course, the remaining 10% would take a lot of time, as always. But we hope that we will be able to show you the results of this automated extraction of personal and place names in Latin inscriptions in a couple of months. So here's a survey of the structure of our onomastic and prosopographic database. Perhaps I should stress that for people and attestations of people, for the time being, we're exclusively dealing with Egypt. For the onomastic database, we have already added the Latin inscriptions and hope to add the Greek material in the not too distant future also. I'm going to skip this slide. What do we do with all this material? Well, to some extent, we do traditional research, quantitative research, such as this one here. Here you can see a study of mentioning the maternal line in personal identification. So traditionally in Greek, you did not normally mention the name of your mother, but we see that in Roman Egypt, people start doing so, and this becomes very fashionable in the 2nd and 3rd century AD, only to disappear quite quickly again in the 4th century AD. So this type of investigation was impossible before the before we had everything in the database, and so it's interesting to see how I won't go into the fact why this is. You have to read our article in Historia. Janne and I have published an article about that. Another thing is double names. So a lot of people had two names in ancient Egypt already, and we also find those in the Ptolemaic and Roman period. Both in Egyptian and in Greek, and you can see if you plot that on a frequency scale that is a very similar distribution to the mother's names. So this is a subject about which Janne has written her PhD, which was recently published, about double names in the Roman period, and her colleague Sandra will publish hers on double names in the Ptolemaic period in the not too distant future. And a third thing which we have done is study Christian names. That's an article I published together with Willy Clarisse in Vigiliae Christianae, studying the rise of Christian names. And of course, the difficult question there is, does it really reflect the rise of Christianity, or is something else happening? We think it does, but not everyone agrees with us, of course. And that brings me to the last section of this talk, and that's social network analysis. All the attestations we have gathered, we thought would be useful for social network analysis. Sorry. Something went wrong, I hope. It will be just a temporary hiccup. I hope you can still hear me. So here is why we were thinking of applying social network analysis. We're inspired by Tom Brugmans, who gave a lecture in Leuven in 2011, and also after that by the book by Ruffini on social networks in Byzantine Egypt. And this is what we thought we would end up with. This is a rather poor spaghetti monster. There's not much spaghetti there. The things we'll show you later are much more substantial. And this is where I give the word to Janne, who will now speak about social network analysis.
Okay, so I started out with DCNE some 2 years ago when starting on a project called Defining the Elite in Roman Egypt. It's a project about the Apogymnasiu and the Metropolitai in Egypt. Those are two social groups that make up the local elite. And I wanted to find out how they were related to each other and how they fit into the larger social legal structure of the Roman Empire. And I thought social network analysis might help me out there to see how they were related to each other. First, a little introduction to network analysis for those of you who are not familiar with it. So SNA is not, it doesn't refer to one specific theory or model. It's more of a collective term referring to several methods used to analyze relations, not only between people. You can also apply social network analysis to organizations or countries or germs, whatever. It's applied to almost every field these days. One of the neat things you can do with SNA is you can quantify those relations and you can visualize them. So that's what we call spaghetti monsters. And when I started out, the problem was there was no one here in Leuven who was doing SNA, so I had to start all by myself, which was not easy. I read a lot of handbooks. I followed this online course on the Coursera website with video presentations. I participated in some workshops to get to know the software. So there was a lot of work. It was a lot of work to become familiar with SNA. I tried out a couple of different software programs like UCINet and R, but in the end I settled for Gephi because it was the most user-friendly. It's free, and you can tweak your visualizations, which is also nice. And it has a lot of the basic SNA functions. So UCINet and R are more advanced, but Gephi has the basics, and it was enough for what we wanted to do with it. So we settled for Gephi in the end. And then a little bit of advertising. So I started up a blog together with a colleague of mine. It's the 6 Degrees of Spaghetti Monsters that Greg mentioned before. In the blog, we explain the basics of SNA, how to get started for people who want to start applying SNA themselves, so they don't have to go through hell learning it all like we did. And we also present our research a little bit. How do you explain the basics of SNA to an inexperienced audience? We use Harry Potter. Everyone knows Harry Potter. Everyone's familiar with Harry Potter. So it's easy to understand what we're talking about if you use this example. So here you see a very rudimentary network consisting of 3 people: Harry Potter, Ron Weasley, and Hermione Granger. The actors in a network are called nodes, and the links connecting them are called edges. This is an undirected network, so by definition it means that all ties are reciprocated. So Harry Potter is a friend of Ron Weasley, and Ron is a friend of Harry. You also have directed networks, and as the name itself says, the links point in a certain direction. In this case, this is a network of who is in love with who. So Ron and Hermione are in love. Harry has a crush on Jo, who also likes Harry, but is actually involved with Cedric as well. And the only non-reciprocated tie in this network is the one between Bellatrix and Voldemort. So Bellatrix was infatuated by the Dark Lord, but he couldn't care less about her, despite what you read on the internet with all the fan fiction. Another thing you can do with network analysis is community detection. Here's another Harry Potter example. So you can group your nodes in your network yourself by adding certain attributes to the network. So like in the first example, I colored the nodes according to the Hogwarts house they were sorted into. So the red ones are Gryffindors, the green ones are Ravenclaws, the yellow ones are Hufflepuffs, and the green ones are Slytherins. In the bottom network's actually the same, but I just colored them differently. So this network is based on the fifth book, The Order of the Phoenix. So in the bottom network, the nodes are colored according to the storyline, more or less. So you have the students belonging to Dumbledore's army on the left. In the middle, you have the Order of the Phoenix. And to the right, you have the Death Eaters. So these groups I discern myself by adding attributes to the network and coloring the nodes according to the attributes. But you can also tell Gephi to detect communities mathematically based only on the links in the network. And when you do that, this is the result you get. And so you can see that on the right side, he discerns the Death Eaters too, but actually the large cluster in the middle, he divides more in a more detailed way than I did. So I just had the Dumbledore's army and the Order of the Phoenix. But here he actually groups together the Weasley family separately. Those are the red nodes. The yellow nodes at the top are the Dursleys, so he detects them as well. And then the blue ones are again the Dumbledore's army, and the purple ones are the Order of the Phoenix. So it's a really neat feature in Gephi to see if you can discern groups in your network. And then the first ancient network I set up was based on the archive of Xenon. So Mark already mentioned Xenon. He was a Carian immigrant who came to Egypt and became an estate manager of a really large estate in the Fayum district in Egypt. The estate belonged to Apollonius. He was the finance minister under Ptolemy II and III. And the archive consists of some 1,800 texts spread over 30 years and mentions some 5,000 people. And if you make a network out of all those people, you get this, which is a really cool picture, but you can't really do anything with it. It's just a big, well, it's a spaghetti monster. And you can't really read anything in it except perhaps the big blue node in the middle is Xenon, but that's about it. So what's more practical is dividing the archive up into different time periods and making separate networks of each time period and comparing them. So that's what I did next. So here you can see two networks. The left network is the network of Banakestor. He was the estate manager before Xenon. And then the network on the right is Xenon's network the first 2 years that he was estate manager. And then you can start comparing characteristics of these networks. So here, for example, I took a look at the density of these networks. So the density measures the amount of cohesion in a network, so how connected the nodes are. And you get a result between 0 and 1, 0 meaning that none of the nodes are connected, 1 meaning that each node is connected to all other nodes. So Banakestor's network has a density of 0.1, meaning that 10% of all possible ties are there, while Xenon's network only has a density of 4%. This seems counterintuitive when looking at the networks. You see more links in Xenon's network, but that's actually because it's bigger. It has 115 nodes. Banakestor's network only has 60 nodes. And the implications of this density become clear when you leave out Banakestor and Xenon. When you look at Xenon's network without Xenon, you see that it actually falls apart into a lot of small unconnected components, meaning that he was kind of the glue that held everything together, while in Banakestor's network, 80% is still connected. So there was a lot more interaction going on there independently of Banakestor. One of the problems I kept struggling with up till very recently was that I could make all these networks, but I couldn't really show them to the public. So what I've been doing up till now in this presentation is showing you screenshots of the network. But it's not really practical because they're static for one. While in Gephi, I can play around. I can zoom in on certain parts of the network and stuff. You can't do that with screenshots. If you're working with large networks, it's not really practical either. Like this is a network of all names in Trismegistos. It consists of 17,000 nodes, but it doesn't really say much. I mean, you don't know what each node stands for. I can add labels, but it just makes things worse, actually. So I was really excited when a couple of weeks ago I discovered the Sigma JS export plugin for Gephi developed by the Oxford Internet Institute, which allows you to export your network in Gephi as a series of CSS and JavaScript and HTML files and upload it to your web server. And then it gives you an online visual which you can play around with. So I tried it out on the names network first. This is a screenshot, but I'm going to go to the live version right now. So this is what you get online. So people can go to the website and can start exploring the network themselves now. So as you can see, if you hover over a node, the labels appear. You can zoom in on the network. So if you're interested in certain parts of the network, you can zoom in on that. And you can also look up specific nodes. So this is a network of all names in Trismegistos based on genealogical relationships. So there's a link from name A to name B if a parent with name A chose name B for his or her child. So it's a directed network. As I said, it was about 17,000 names. And there are some 70,000 links between the names here. So you can get a feeling for how names were connected. And I colored the nodes on the basis of their linguistic origins. So blue nodes are Egyptian names, and green nodes are Greek names. So you can see that there's a clear division into an Egyptian and a Greek component here. Oh yeah, so what we could also do, because each node is also assigned a specific URI, so what we can also do now is connect these networks to our online database. So if you look up a certain name now in Trismegistos, you not only get the basic information, so language, translation, attestations by century, attestations by provenance. We also have a list of all the name variants here at the bottom, but you also get the network for each specific name, which names it's connected to. So that's a new feature we've implemented in Trismegistos right now as well. I also tried Gephi's community detection algorithm on this network, and the result was pretty neat. So as you can see, Gephi also divides the network into two big components that roughly coincide with the Egyptian and the Greek part. And it would be nice now to take a look at those names which are, for example, Egyptian in origin, but are classified by Gephi in the Greek component, or the other way around, because This means, for example, that indigenous names were accepted by Greek families, or the other way around, that Egyptian families took over Greek names. So that's something we're going to take a look at soon, for which the community detection can help us out. I've also tried making a network of place names. This is the preliminary result. I haven't put this network online yet because I've been struggling with the layout. So although this network only has 10,000 nodes, that's less than the names network, it has about 200 links. So these place names are linked if they appear in the same text. Gephi's been struggling with the layout. It's taking a long time to get the layout right. So he started pulling apart some communities, like the red nodes you can see are mostly place names in the Fayum. But in the middle, there's still this gigantic unstructured blob that needs to be sorted out. But I have colored these nodes according to the community detection results already. So the colors more or less represent different districts in Egypt. So the algorithm works in this case as well. But this network is not available online yet. Once it's finished, we're going to put it online, and you can look it up. Well, you can look up place names online as well. And then for the last two networks, Mark's going to take over because I drew them, but he's the brains behind them.
Thank you, Jana. So this is just a bit of a spielerei to end with, but this all came about because someone asked a question on the papyrist asking to be able to look for papyri that were published after 1980, and I realized that this information was available to us in the FileMaker version but not online, and then I started thinking about doing things with the online version, not only with the date but also with the editors, and also with the help of the papyrological community. I added an editor to almost every Greek papyrological text which was in our database. And afterwards I thought, well, it would be nice to do the same also with our bibliographical database for Demotic, the Demotische Literatuurübersicht, and maybe also for the Bibliographie Papyrologique, the Greek papyrological database. And you can then also make a network, which I asked Jana to do, of course, of co-authorship. And the interesting thing is that then, this is a screenshot, but if I go here, you should normally be able to see. You can then have a look at a network of co-publication, and this is being colored by the number of co-authors. So in dark red, you can see people who have worked together with many other people and are thus quite central in the network. Whereas the size of the bubbles is the number of publications they have in this specific network. So you can actually then play around with it. This is my teacher, Willy Clarisse. He's a quite important person in the network because he's published together with 27 people, but he has 85 publications in the Demotische Literatuurübersicht. Whereas a name such as Eugène Reviou, the notorious French dematist at the late 19th century, he has a very big note because he has published quite a lot, 180, but he's published together with very few people. Not surprising because, yeah, he wasn't the most popular scholar around, I think. So this is a network of co-publication, and it's of course only one way of approaching the evidence or the material which is available. Here you can see a network of co-authorship in the Bibliographie Papyrologique. It's a much larger set of data, of course, than the Demotische Literatuurübersicht. But you can also explore that, and you can, well, you can just type in any name. Let's now do Bagnall, and then you see here, this is Bagnall's network. These are all the people he has collaborated with, and you see the line, the No, the edge, yes, I always forget that word, edge. The edge is much thicker because he has worked together quite a lot with Klaas Worp. So we also show this information online now. Well, not yet, but we will do as soon as we put the. Oh, that's mine. That's a bit vain. I should use someone else. Someone else's. Okay, let's see. Alain de Lattres, yeah. So here you can see, here's the number of publication. You can get a list if you want to see which text he has edited or which articles he has authored. But also here you can see his network in the Bibliographie Pathologique, which people he has published together. Okay, so that was about what we wanted to say. I don't know whether it's time for questions. I'm afraid we were late, but we didn't realize we were late because we thought we would only start about 10 minutes ago. There must be some problem with the difference in hours, but I hope it was interesting for you nonetheless.
Yeah, the mic and everything.
Okay, can you hear me? Or we're not getting.
You're still muted.
Yes, I can.
No, I'm not muted.
And how about your sound?
Can you hear me? It doesn't. My machine doesn't think it's muted.
There you go.
Can you
That's
hear
on my
me?
screen. My screen. That's the other screen.
I can hear you.
Like this. Mark, can you hear us?
Yeah,
Yes.
you can hear me.
Great.
Okay. All right. So the answer to your question is we're only 5 hours apart right now instead of 6.
Ah,
So this is a.
the 1 week which where this is the case.
That's right. So that, we should have warned you. It's been something it happened a couple of weeks ago, so we're accustomed to it in Germany, or those of us going back for it. But that's the confusion. Anyway, here is the audience. So questions? Yes, Frederick Baumgart.
I've got two questions, mostly related.
And you maybe walk up so we can hear.
Yeah, okay. So hi, Mark and Janne. Nice talk. I got 2 questions, mostly relating to the later part. The first would be, what algorithms specifically did you use for the community detection? And if you use different ones, I'd be interested to hear about your experience, whether the kind of the identity when you compared the clustering to your manual annotation of Greek and what was the second one? Latin names or Egyptian and Roman names. How that identity changed or the similarity changed if you used different algorithms. And the second question, or rather suggestion, would be on an interesting point. We see a lot of citation networks is in scientometrics based on very formalistic parameters, specifically who quotes whom. And what I would like to see is a text mining based analysis. Say, look at, so you've got the what you have right now based on explicit citation, and comparing that to the actual use of words in those articles, and see how that maps to the more formalistic network.
Okay, so can you still hear me?
Yes.
Yeah. So, I'm hearing myself. Can you switch that up? Yeah, okay. So, to answer the first question, the community detection is still in our initial. We are not really yet experimenting with different types. It's just the first exploration, so to say. This is very much way of dealing with it. Because we're new to the subject, we could appreciate any kind of help or systems you can assist us with. The second one about citations. So ours is actually not a citation network. It's a co-author network. So it's not Who quotes to, but Who publishes together with Who. And of course, citation networks also be interesting, but different data, of course, for them. Right now, we have based ourselves on this graphical database that were available to us. But it's really a bit of standardizing our author information in our database.
Great, thanks.
Okay, thank you. And let's see, we run out of time in 5 minutes because of our schedule. But I wanted to ask, or Thomas, you have a question. Thomas Trimkis.
I just have a technical question. Did you on purpose, or what was the reason you opted for the Oxford visualizer? So is there a reason why you actively decided against Sigma.js, and probably even more importantly, Sigma.js to visualize Gephi, or just taking the raw network data and visualize it with D3? Is there a reason, just out of interest?
The Oxford visualizer actually works with Sigma.js. It's just a plugin
Okay.
which converts your Gephi to Sigma.js. So it's not. It just makes it easier for people like us who are not very familiar with languages to explore visualization.
Okay. All right, well, I'll make one final comment before we let you go, which is that we're constantly hearing about, well, humanists have to do single-authored publications. I think the single-authored publications correlate to negatively to prestige and intellectual activity in a field. The biggest and most active fields in academia have a lot of co-authorship. But your graphs are wonderful because of the way they demonstrate the 2 dimensions of authorship, where it's not just how much stuff you publish, but who you published with. And I loved your final comment, because when I spend my time reading computer science, ACM publications, and reviewing them, if I see a paper that doesn't have co-authors, my first question is, what's wrong with this person? Doesn't he have any friends? I mean, even if you did write the paper all yourself, you've got to invite your friends to be co-authors just so you don't look like a jerk. So it's kind of like the opposite of what we're used to. But you've really given us a little instrument whereby we can make that point, visually at least. And I will try to do that in the future. So thank you very much, Mark and Jana.
Thank you.